April 8, 1943. The sky over occupied France was clear at an altitude of 27,000 feet. Up there, Oberleutnant Ralph Hermikin watched through the crystal-clear canopy of his Focke-Wulf 190A5, what he believed to be a ridiculous spectacle. Below his formation, climbing with difficulty, were the heavy and clumsy silhouettes of the new American fighters. Hermikin, a veteran of Jagdgeschwader 26, couldn't contain his laughter. "Their army sent us flying milk bottles," he told his wingman, laughing. Apparently those planes were too slow, too big, everything a fighter shouldn't be. The enemy made its debut in the skies over Europe with machines that looked more like trucks than combat aircraft. Below, 16 P-47C Thunderbolts from the 4th Fighter Group were slowly gaining altitude. Their 2,000 horsepower Pratt & Whitney R2800 engines roared under maximum effort, dragging nearly 7 tons of metal, fuel, and ammunition. The scene seemed to confirm every prejudice of the German pilots. Accustomed to the sleek lines of the Spitfire and the lethal balance of the Messerschmitt and Focke-Wulf, the Germans now saw pot-bellied fuselages, short wings, and huge propellers spinning in front of glass domes that looked more like greenhouses. To them, this was not a threat. It was an engineering mistake. But what no one in the German formations could have imagined was that those clumsy aircraft carried within them the weapon that, in a few months, would completely change the course of the air war. Amid the laughter of Luftwaffe veterans, the Thunderbolt made its discreet debut as an anomaly that defied the known rules of fighter aviation. At that moment, however, no one saw it that way. What they saw were heavy giants trying to keep up with the climb of enemy fighters. The P-47 seemed anything but a worthy opponent. The American commander of that mission, Major Donald Blakesley, a veteran of the Eagle Squadron who had flown Spitfires in the RAF, knew that surviving in that new fighter required more than bravery. It was necessary to relearn how to fight. The Thunderbolt was not designed to circle around the enemy or compete in tight turns. It was a machine of altitude and power, a concept that broke with all the combat philosophy used until then. While the Germans relied on lightness and maneuverability, the Americans had designed a metal fortress with a single idea in mind: to resist, climb higher, and fire with overwhelming force. The P-47 was the result of an urgency born 3 years earlier. In 1940, when France fell under the Blitzkrieg, engineer Alexander Kartveli, born in Georgia and based in the United States, received a request from the U.S. Air Force to build a fighter capable of facing the best Luftwaffe planes at high altitude. Kartveli responded with something that seemed absurd: a nearly 10-ton monster equipped with an 18-cylinder radial engine and a turbo-supercharging system that occupied much of the rear fuselage. It was, as he himself said, a dinosaur, but a dinosaur with good proportions. When the XP-47B prototype flew in May 1941, even the engineers doubted it could get off the ground. But it flew, and, more importantly, maintained full power at 27,000 feet, an altitude at which German engines were already beginning to suffocate. The secret was in the huge turbocharger, powered by exhaust gases, and capable of providing atmospheric pressure equivalent to sea level even in the upper layers of the atmosphere. The appearance was grotesque, but the performance was unprecedented. Still, this advantage was theoretical. What pilots saw in 1943 was a machine that was dangerous even for those who flew it. Training for the new fighter had been brutal. Between September 1942 and January 1943, the 56th Fighter Group lost 18 pilots and 41 aircraft in accidents. The P-47 was unstable on takeoff, violent in torque, and prone to compressibility dives that froze the controls. Many said that the aircraft killed more Americans in training than Germans in combat. However, those who managed to master it discovered something extraordinary: raw power, stability at high speeds, and a resilience that defied logic. "It was like strapping yourself to a locomotive," recalled Lieutenant Robert Johnson, who would later become one of the United States' greatest aces. On that April 8th, none of these qualities were evident. What could be seen were heavy aircraft trying to maintain formation, while, above them, Focke-Wulf fighters prepared their attack. German radios picked up confident, almost amused voices. The enemy, they thought, would not last a month in the skies over France. The first dive of the 190s came quickly. The Thunderbolts reacted with difficulty, weighed down by their own mass, slow to turn, unable to climb alongside the attackers. Within minutes, the first American losses were confirmed. For observers on the ground, it was confirmation that the Luftwaffe still dominated the air. The laughter, however, was beginning to crack. One of the P-47s had returned from the mission riddled with dozens of 20mm shells, with holes in its wing, cowling, and even vertical stabilizer, and yet it had landed safely. The radial engine, without a liquid cooling system, had withstood impacts that would have destroyed any water-cooled fighter. Another pilot reported that, when he opened fire, his battery of 8 50-caliber machine guns had turned the target into fragments in less than 2 seconds. No one yet fully understood what this meant, but the signs were there. Something about that grotesque machine was different. On the front lines, German intelligence reports recorded the first observations. Large aircraft, inferior maneuverability, but exceptionally sturdy structure. It was still a neutral comment without strategic weight, but it already revealed curiosity. Subsequent attacks showed that, despite their disadvantage in turns, the Thunderbolts could withstand unbelievable damage, and when diving, reach speeds that caused the instruments to vibrate beyond their reading limit. A pattern was beginning to form, still imperceptible to those who laughed at the enemy. Meanwhile, on the American side, commanders were adjusting their doctrines. Donald Blakesley and Hubert Zemke understood that the key was not to compete with the Germans in maneuvers, but to exploit what was unique about the P-47: power, altitude, and firepower. It would still take months for this philosophy to take hold, but the beginning was there, on that first mission, where German laughter echoed over the radios, and American pilots learned, under live fire, to understand their own machine. The story of the P-47 Thunderbolt thus began with mockery. In the eyes of the Luftwaffe, it was just another American mistake, a slow giant doomed to failure. But in the maintenance workshops, in the hangars of England, and on the engineering drawing boards, something bigger was in motion. Behind that clumsy appearance was engineering that the Germans did not yet understand, and that they would soon be forced to study closely. What was a joke to them in 1943 would soon prove to be one of the most lethal instruments ever created by military aviation. The laughter was just beginning to fade. The transformation of the Thunderbolt began long before the skies of France. In 1940, when German forces swept across Europe, the United States realized it needed a fighter capable of combat at high altitudes, above the range of conventional aircraft. The request landed on the desk of Alexander Kartveli, chief engineer at Republic Aviation. The result was not just a new aircraft, but a completely different concept. The XP-47B project, designed amid haste and uncertainty, incorporated mechanical solutions that surpassed anything the Luftwaffe had ever seen. Instead of lightness, Kartveli focused on structure. Instead of maneuverability, he focused on strength. And instead of fragility, he created a fortress. The first prototype, which flew in May 1941, looked like an aberration by the standards of the time. It weighed almost 10,000 pounds empty, more than some medium bombers. A huge 18-cylinder Pratt & Whitney R2800 radial engine dominated the front fuselage, powered by a turbo supercharging system that ran through the entire body of the aircraft. The turbo, installed at the rear, was connected by a complex set of ducts and valves that used exhaust gases to compress the intake air. This arrangement allowed the engine to maintain full power at an altitude of almost 9,000 meters, a feat that German liquid-cooled engines simply could not match. On the test fields, the pilots were suspicious. The aircraft was heavy, slow to take off, and required constant attention to torque. But as the P-47 climbed, the transformation took place. The plane gained stability, vibrations decreased, and performance became increasingly impressive. No other American fighter could maintain such high power so far from the surface. The maximum speed exceeded 680 kilometers per hour, and in a dive, the Thunderbolt could reach close to the sound barrier, something unthinkable in 1941. As the first operational units were delivered, Republic and the U.S. Air Command began to release technical data that caught the attention of German intelligence services. The Luftwaffe obtained photos, reports, and even fragments of downed aircraft. In August 1943, one of them was recovered almost intact after a forced landing in occupied France. The fighter was taken to a German test center, where engineers began a detailed analysis. The report, kept secret until the end of the war, revealed the technicians' astonishment. They found a fuselage built like a bomber, reinforced stringers, thick ribs and riveted panels with wide margins, designed to withstand forces of up to 12 Gs. The engine compartment was impressively armored. Steel and hardened aluminum plates protected the pilot and vital systems. The canopy, made of thick glass, could withstand impacts that would destroy any European fighter. And most surprising of all was the redundancy. Each control had dual cables with independent routes, ensuring operation even after severe damage. The weaponry also shocked the evaluators. The Thunderbolt carried 8 .50 caliber Browning M2 machine guns, 4 on each wing, fed by a total of 3,400 cartridges. German engineers calculated that the full burst of these weapons could fire almost 100 projectiles per second, creating an impact zone capable of disintegrating any aircraft in less than 2 seconds. The incendiary and armor-piercing ammunition, with tungsten and phosphorus cores, was designed to penetrate armor and ignite the internal fuel of targets. To ensure operation at high altitudes, the feed system was electric and heated, preventing freezing. During flight tests with the captured model, the results were even more surprising. The aircraft maintained constant acceleration up to 9,000 meters, where the Focke-Wulf and Messerschmitt lost power. High-speed stability was so great that test pilots had to reduce force during dives to avoid exceeding structural limits. High fuel consumption was the main limitation, but the German report acknowledged that the turbo-supercharger's performance was extraordinary and not yet reproduced by German engineering. These reports reached Adolf Galland and Hermann Göring, accompanied by comments from the technicians themselves. The American fighter is heavy and inefficient at low altitudes, but its performance at high altitudes and its ability to absorb damage are remarkable. No current German aircraft can sustain combat above 8,000 meters against this model. Despite this, Luftwaffe commanders remained convinced that tactical superiority would compensate for technical differences. In the United States, while the Germans studied the captured model, Republic engineers perfected the design. New variable pitch propellers improved climb performance, and minor aerodynamic modifications corrected the tendency toward instability. Each version that left the assembly line was more refined than the previous one. The P-47 went from being a problematic prototype to a versatile combat platform, ready to operate in any theater of war. At the same time, pilots began to understand the fighter's true potential. Major Hubert Zemke, who initially hated the Thunderbolt, realized that the key was to use its weight and power to his advantage. Instead of competing with German fighters in turns, he taught his squadrons to fight vertically, dive from high altitude, attack at high speed, and climb again before the enemy could react. The Thunderbolt didn't need to be agile, it just needed to be fast and deadly. In the Luftwaffe hangars, the test results spread quietly. Engineers compared torque and lift measurements and recognized that although heavy, the P-47 had safety margins well above German standards. The aluminum alloy parts were thicker, the heat treatment was more advanced, and the precision of the machining indicated a level of industrial standardization that Germany, under bombardment and material shortages, could no longer maintain. By the end of 1943, the Thunderbolt was no longer a laughingstock and was beginning to be treated with caution in intelligence reports. German analyses went from sarcastic comments to serious assessment. Heavily armed, extremely resistant, and with exceptional performance at altitude. It was technical recognition that something had changed. For the first time since 1939, the Luftwaffe faced an adversary that could not be shot down with skill alone. In the following months, American factories would go into full swing. Each assembly line worked day and night, and mass production shaped hundreds of Thunderbolts per month. What had started as an experiment became a symbol of large-scale industrial engineering. The machine that had once been laughed at was now studied with respect and fear. The Germans knew they were facing an aircraft that combined power, armor, and firepower in a single metal body. What they didn't know was that the worst was yet to come, when American pilots would learn to exploit all this potential in the skies over occupied Europe. Air warfare was about to change forever. And if you want to follow how this change transformed the laughter of German pilots into pure despair, remember to subscribe so you don't miss the rest of this story. The turning point came in the summer of 1943. The fighting over France and northern Germany began to show a quiet change. Until then, Luftwaffe combat reports described the P-47 as a slow, unresponsive, and easy-to-hit aircraft. But starting in June, reports began to emerge that contradicted this perception. The most notorious case occurred on June 26, 1943, when Second Lieutenant Robert S. Johnson of the 61st Fighter Squadron single-handedly took on a group of Focke-Wulf 190s over Lille. His P-47 was hit by more than 200 projectiles, including direct hits from 20mm cannons. The cockpit was covered in oil, the fuselage was torn, and the engine cowling was partially destroyed. Even though he was wounded and had no visibility, Johnson managed to stabilize the plane and fly it back to England. What happened on that flight defied all estimates of structural strength. The fighter withstood impacts that would have destroyed any aircraft of the time. When it was inspected on the ground, mechanics stopped counting holes when they reached 200. Word spread quickly and the message was clear. The Thunderbolt could continue flying even after sustaining an absurd amount of damage. From then on, the Americans began to explore the aircraft's true potential. Commander Hubert Zemke reviewed the flight reports and identified a pattern. The P-47 was not competitive in turns or slow climbs, but it was virtually invincible in a dive. At high altitudes, its radial engine and turbocharger maintained full power, while the Germans lost strength. Zemke reorganized the tactics of the entire group. The boom and zoom method was born, diving at extremely high speeds onto the enemy, firing a short, devastating burst, and climbing back up before being hit. The formations began to operate above 30,000 feet, taking advantage of the maximum service ceiling that no German aircraft could safely reach. The result was immediate. During the attacks on Schweinfurt and Regensburg in August 1943, the P-47 formations proved their new effectiveness. The columns of B-17 bombers were now escorted by fighters that dove on German interceptors like human projectiles. The sound of 8 machine guns firing in unison created a wall of fire that left enemy pilots with no chance to maneuver. German reports of the operation describe fighters disintegrating in the air, hit by bursts so concentrated that they resembled saw cuts. A single Thunderbolt could fire 3,400 projectiles per mission, mixing armor-piercing, incendiary, and tracer ammunition. It was enough firepower to destroy an aircraft in 2 seconds. Luftwaffe units began to realize that something was wrong with their own assessment. Traditional tactics, based on controlled dive attacks and vertical escapes, no longer worked. Instead of hunters, the Germans had become targets. In October 1943, legendary pilot Hans Philipp, one of Germany's most experienced aces, was shot down during an interception of bombers over Bremen. His Focke-Wulf 190A was hit by a P-47 that dove from 32,000 feet. The attack was quick and lethal, 30 degrees of deflection, 300 yards away, and the enemy aircraft exploded in mid-air. Philippe did not have time to bail out. The episode symbolically marked the end of German confidence in their technical superiority. A few months later, a new variant of the Thunderbolt arrived in Europe. The P-47D-22, equipped with a Hamilton standard propeller with wide blades, called a paddle blade. This modification dramatically increased the climb rate and acceleration performance. For the first time, the heavy American fighter could climb alongside the Focke-Wulf and even outperform them in some conditions. The new propeller also generated a distinctive sound, a deep, continuous roar, the result of the blade tips exceeding the speed of sound. German soldiers on the ground quickly learned to recognize the noise. They nicknamed it Donnerschlag, the thunder that kills. During the winter of 1943 and early 1944, the P-47s consolidated their dominance of the western skies. In March, long-range missions began with external fuel tanks, allowing bombers to be escorted to the heart of Germany. American formations now flew in 3 levels: a high layer of Thunderbolts, a middle layer of P-51s, and a lower layer of P-38s. The airspace over the Reich was no longer safe for the Luftwaffe. Every attempt to intercept the bombers resulted in unsustainable losses. In June 1944, during the invasion of Normandy, more than 500 P-47s provided direct air cover over the beaches. The operation was a brutal demonstration of air power. American aircraft were at all altitudes, from a few meters above the sea to almost 10 kilometers high. German pilots who attempted to penetrate the landing zone encountered an impenetrable wall of fire. Oberleutnant Wolfgang Fischer, one of the few who managed to reach the coast, later reported, "The sky belonged to the Americans. They were everywhere. When we tried to climb, they dove. When we descended, they followed us. No one escaped." Shortly after D-Day, the Thunderbolt took on a new role. With the advance of ground troops, it began to act as a fighter bomber. Equipped with 500 and 1,000-pound bombs under its wings and central body, as well as 5-inch rockets, the P-47 became a machine of ground destruction. The bursts from the 8 machine guns tore through columns of trucks, locomotives, and tanks. In a single month, the Thunderbolts destroyed thousands of vehicles and disrupted virtually all of the Wehrmacht's daytime transport. The word Jabo, short for Jagdbomber, became synonymous with terror among German troops. On the battlefield, the consequences were visible. With each attack, entire supply columns disappeared under fire. Aerial reconnaissance images showed trails of black smoke cutting across roads and railways. No convoy could move in daylight. German units began to move only at night, which drastically reduced their ability to respond. Even anti-aircraft artillery, including the dreaded 88mm guns, had difficulty keeping up with the P-47s, which appeared at high speed, attacked, and disappeared before the guns could adjust. As the front approached the German border, enemy engineers attempted to develop countermeasures. Improvised camouflage, extra armor plates on trucks and tanks, and new dispersal tactics were employed. Nothing worked. Concentrated bursts of 50-caliber fire-pierced light vehicles and penetrated the tops of armored vehicles, their most vulnerable point. The characteristic sound of HVAR rockets tearing through the air preceded devastating explosions. On many fronts, the roar of Pratt & Whitney engines was enough to send soldiers abandoning their posts in search of shelter. Operational results confirmed the success of the transformation. In a few weeks, the P-47 went from being seen only as an escort fighter to becoming the main instrument of the Allied air offensive. Its robustness allowed it to fly over anti-aircraft fire, withstand damage, and return to base safely. The survival rate of pilots rose while that of the Luftwaffe plummeted. Missions that once required meticulous planning became routine. American air superiority was now absolute. The change that began with the unlikely resistance of a single pilot had turned into a new type of air warfare. By the summer of 1944, the Luftwaffe no longer had the means to challenge the power of the Thunderbolts. The combination of altitude, power, and firepower had redefined the rules of combat in the skies over Europe. What had begun as mockery had turned into technical and tactical despair. The P-47 was no longer an easy target, but had become the inevitable sound of defeat echoing over the ruined cities of the Reich. By early 1945, the Luftwaffe existed more on paper than in the air. The force that, 2 years earlier, had dominated the skies over Europe now barely managed to keep aircraft in operation. There was a shortage of fuel, pilots, and spare parts. German squadrons were reduced to scattered groups, composed of young men with few flying hours and exhausted veterans who knew the end was near. Meanwhile, Allied hangars remained full, supplied daily with new Thunderbolts fresh from American factories. The gap between the two forces had become insurmountable, and the P-47 Thunderbolt was the most obvious symbol of that distance. The Allied air offensive at the beginning of that year reached industrial proportions. The United States produced a new Thunderbolt every hour. On Long Island, the Republic Aviation Factory operated 24 hours a day, and another plant in Evansville, Indiana, delivered 500 aircraft per month. In all, more than 15,000 P-47s were built, a number that Germany could not match even in its wildest dream. Each plane was a combination of 65,000 parts, 8,000 meters of electrical wiring, and more than a ton of aluminum, assembled with precision by a workforce trained in just a few months. The American ability to replace losses contrasted with the German reality. On January 1, 1945, during Operation Bodenplatte, nearly 900 Luftwaffe fighters were launched in a surprise attack on Allied bases in Belgium and the Netherlands. The goal was to destroy aircraft on the ground and temporarily regain air superiority. The attack succeeded in hitting some runways, but the cost was devastating. 271 German planes shot down, and more than 200 pilots killed or captured in a single day. At Y-34 Airfield in France, Major George Brooking, commander of the 365th Fighter Group, watched the destruction of part of his fleet. When a German prisoner pointed to the wreckage and sarcastically asked what he thought of it. Brooking replied coldly, "Tomorrow we'll have 40 new ones. How long will it take you to replace your men?" And indeed, in less than 2 days, the hangars were full again. New P-47 D-40s arrived from England ready for combat. The Luftwaffe never recovered from Bodenplatte. The loss of experienced pilots was irreparable. The Americans, on the other hand, with their standardized training system, produced 30,000 pilots a year. Each new fighter arrived at the front with more than 400 flight hours and complete mastery of tactics and weaponry. During the same period, new German pilots were thrown into combat with less than 100 hours of experience. The difference in preparation was directly reflected in the results. While industry and training sustained the Allied effort, the Thunderbolt's performance constantly evolved. The final versions, such as the P-47 and P-47N, were equipped with methanol-injected engines and increased power to almost 2,800 horsepower. These variants reached speeds of over 750 km/h and were able to intercept even the Messerschmitt Me 262 jets during takeoffs and landing. The P-47N, adapted for the Pacific, had additional fuel tanks integrated into the wings and a range of over 3,700 kilometers, allowing it to escort bombers to Japan. It was the same concept that had emerged as a flying monster in 1943, now transformed into the most versatile combat platform of the war. The results spoke for themselves. In Europe alone, the P-47s destroyed more than 3,700 aircraft in aerial combat, 3,300 on the ground, and more than 9,000 locomotives. They were also responsible for the destruction of 86,000 railroad cars, 6,000 armored vehicles, and about 68,000 trucks. No other Allied fighter bomber achieved such effectiveness. In the Pacific theater, the performance was similar. Nearly 700 Japanese aircraft shot down, and hundreds of ground targets destroyed. The loss rate was also impressive. With hundreds of thousands of missions flown, the P-47 maintained one of the lowest kill rates of the war. German engineers who analyzed the wreckage and captured examples of the Thunderbolt openly acknowledged that they had never designed anything comparable. The final report, found after the collapse of the Third Reich, classified the P-47 as the most rugged and well-armed combat aircraft ever mass-produced. The description highlighted its reinforced fuselage, 10mm armor around the cockpit and engine, and incredible ability to withstand damage without losing control. The engineers concluded that it would be impossible to reproduce anything similar under the conditions of the German industry in 1944 and 1945, already exhausted and disorganized by Allied bombing. For the surviving German pilots, the sound of the 850 caliber machine guns became unforgettable. Many described the Thunderbolt's bursts as a continuous rain of steel, impossible to escape. Some reported physical symptoms before missions against P-47 formations, a state of tension dubbed by military doctors as Jabbo fever, fighter bomber fever. The mere roar of a radial engine on the horizon was enough to cause panic. Ground troops abandoned vehicles and ran for the trenches at the first sign of the sound. American air superiority was absolute until the last days of the war. In April 1945, the remaining Luftwaffe units were virtually immobilized due to a lack of fuel. Even so, some tried to resist. The result was always the same. P-47 formations intercepted the few German planes that still managed to take off and destroyed them before they reached their target. Lieutenant Klaus Brettschneider, who flew one of his first missions in March of that year, survived by chance after being attacked by 4 Thunderbolts. His account is straightforward. "They dove on us as if they were falling from the sky. The first shot hit me before I could react. My wing exploded, and the engine caught fire. It was all over in less than 15 seconds. By the end of the war, the Luftwaffe had lost around 28,000 pilots and almost its entire fighter fleet. American industry, on the other hand, ended the conflict with thousands of aircraft in stock and ready for delivery. The difference between the two powers was a true reflection of all the industrial and logistical effort that defined World War II. The P-47 did not win by chance. It won because it was built to withstand, fight at any altitude, and operate under any conditions. The plane that started out being ridiculed as a flying barrel became the most feared fighter bomber of its time. In post-war meetings between veterans, even former enemies acknowledged its superiority. In 1985, during a pilots' reunion in Phoenix, General Adolf Galland, former commander of the Luftwaffe, stated on camera, "We laughed when we first saw it. We said it was a bomber disguised as a fighter. We were wrong. They understood what we did not, that in a war of attrition, the aircraft that can take more punishment and fire more wins." It was the definitive acknowledgement that the initial laughter had turned into complete defeat. The P-47 Thunderbolt ended the conflict as the heaviest single-seat fighter aircraft in history to enter mass production. Its reputation spanned generations as a synonym for power and durability. When the last example stopped flying decades later, it was still remembered for the unmistakable sound of its engine and the impact of its weapons. In 1943, the Germans laughed. In 1945, there was no one left to laugh. Given all that has been documented, what do you think could have been different in this outcome? Would the Luftwaffe have found another way if it had understood earlier what it was facing? If you liked this content, like, share, and subscribe now to the channel to follow the next stories that reveal the behind-the-scenes of the greatest air battles in history.